So let's start. Hello, everyone, and a very good morning to all of you joining us from different parts of the world today. A very warm welcome to all our respected authors and invited guests. So, we are now attending technical session 7E. My name is Yashita, and I'll be your moderator for this session. I'm truly delighted to be here with all of you and looking forward for a very smooth, engaging, and a knowledge-packed session together. So, on behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it gives me a great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025. So, this year is a very important year for us. This is the 10th edition of ICTCS and it is being conducted in a hybrid mode. So the physical conference was successfully held yesterday in Jaipur, and today and tomorrow, today, it is 16th and 17th December, so we are connecting virtually. So wherever you're joining us from today, thank you for being part of this special edition, and let's make the most of this digital time together. So we have an excellent lineup of presentation scheduled for this session, covering diverse ideas, research insights, and very innovative approaches. So I'm sure you'll find today's discussion informative and engaging. So even in an online setting, the exchange of ideas and perspectives will truly bring life to our session today. So before beginning with the sessions, I will give a quick overview of how the sessions will run today. So we have 10 presentations scheduled in this session. Each presenter will give 10 minutes for their presentations, followed by a 2 to 3 minutes for their question and answers with the session chair. And at a 9 minute mark, I will give you all a gentle reminder to help manage time so that the session will be on the track. So we kindly request all the participants to stay connected with us until the closing remarks. And your presence and engagement will be add great value to the session. So if you have any questions, clarifications, or updates during the session, please feel free to put them in the chat box and I'll be happy to assist you with it. So before we begin with the paper presentations, it is my pleasure to introduce the session chair for this session, who is Dr. Bhilaji Shinde. He serves as Dean Academics and Professor at Nutan Maharashtra Institute of Engineering and Technology, Pune. With 15 years of experience in the education field at various academic levels, he is a senior member of IEEE as well. He has published more than 20 research papers in reputed journals and conferences. His key areas of expertise includes artificial intelligence and Internet of Things, IoT. So, sir, we are honored to have you with us today, and we would like to invite you to share some welcome remarks.
Hello,
Yes, sir. Good
I'm audible.
morning. Yes,
Good
you are
morning.
audible, sir.
Good morning, one and all. And first of all, thanks for giving me the opportunity to this participation here for this well-reputed IEEE conference. And basically, this is not only the platform, but this is the kind of the well-known, uh, well-known platform for their ideas, their innovation, their inventions, and whatever the result produced during this research, that research is helpful for the future use, for the society use, for the industrial use. And that's why really it's a very good opportunity for all the researchers to represent their idea and thoughts to this valuable conference. So please start the conference. Thank you.
Okay, thank you so much, sir, for your remarks. So, all right, let's begin with the paper presentations for this session. So, our first presenter is J. Gayatri, who will present her work titled A Hybrid Grey Wolf and Whale Optimization Based Feature Selection Method for Intrusion Detection System in Wireless Sensor Networks. So, Gayatri, are you ready with the presentation?
Yes, ma'am.
Yes, so you can share the screen and begin with the presentation.
Ma'am, is my screen visible, ma'am?
Yes, it is visible. You can start.
Oh, thank you, ma'am. Good morning, respected session chair and distinguished participants. I am J. Gayatri, a research scholar in Department of Electronics Engineering in Pondicherry University, and my co-author is my supervisor, Dr. K. Anusudha ma'am, serving a associate professor in the same department in Pondicherry University. Today, I will be presenting a work titled Hybrid Grey Wolf and Whale Optimization Based Feature Selection Method for Intrusion Detection in Wireless Sensor Networks. So, this work focuses on improving the intrusion detection performance in wireless sensor networks using a hybrid meta-heuristic optimization feature selection technique. So I will begin with a brief introduction to wireless sensor networks, followed by the proposed methodology, which is a hybrid gray wolf optimization and whale optimization algorithm feature selection strategy. Finally, the simulation results and conclusion. So let's begin with the introduction. The wireless sensor network is a network of spatially distributed sensors dispersed in an area to collect data information such as the temperature, humidity, wind, and so on. These networks are widely used in many applications, including environmental monitoring, healthcare systems, smart agriculture, smart cities, and military surveillance, and various Internet of Things applications. So, in fact, wireless sensor networks form a core backbone of IoT ecosystem, enabling real-time data sensing and communication. And however, a major challenge in wireless sensor network is that sensor nodes have severely limited resources, such as because usually the sensor nodes are very small in size, so it has a limited battery power, memory, processing power, bandwidth, and which makes them highly vulnerable to security attacks. So denial of service attacks are the most prevalent wireless sensor network attack, which disturb the network communication. So in denial of service attack, the attacker attempts to disrupt the network services partially or completely. So in the effect of attack, the services of network will shut down completely, or will the network services will slow down. So in this slide represents the prime motivation for the feature selection. So the DOS attack can generate the massive amounts of high dimensional traffic data. So this complexity is actually a disadvantage for detection system. So if we use the full feature set, we encounter many issues like a computational burden. It becomes unnecessarily high. And second, many features are redundant or irrelevant, which acts as a noise, and it can actually degrade the detection performance of the classifier. Therefore, the objective of this work is to create an efficient selection method that does three things: that reduces the dimensionality, eliminates the noise, and ultimately improves the classification accuracy. So this is where our hybrid gray wolf and whale optimization approach comes in. So this slide introduces the hybrid meta-heuristic feature selection framework, which combines the gray wolf and whale optimization method. So these two optimization methods are powerful nature-inspired algorithm. So the gray wolf optimizer is inspired by the dominance hierarchy and predatory strategy of wild gray wolves. So the social hierarchy of wolves are structured as alpha, beta, delta, and omega. So the alpha wolves are acted as the superior wolves, which dominates three other wolves. So this algorithm is inspired by the gray wolves, and the whale optimization algorithm is inspired by the special food-seeking behavior of whales. So the whales are producing the bubbles around the prey in spiral shape to capture its prey. So this whale optimization algorithm is based on the bubble net strategy of whales. So I'm combining these two algorithms to select the optimal feature subset in with the random forest classifier. So to eliminate the redundant data attributes. Next, this this slide represents the overall methodology of the proposed technique. So the process begins with the data set. So I used the publicly available data set, which is a wireless sensor network data set. It is a specialized data set for wireless sensor network. So it comprises the 19 attributes and 3,74,661 instances, which contains the 4 types of DOS attacks. That is the black hole, gray hole, flooding, and scheduling attack, also the normal traffic. So after selecting the data set, the all attack types are converted into numerical form for the consistency. And after that, the features are scaled to 0 to 1 to prevent the features with larger magnitude to dominate the model. So after label encoding and normalization, hybrid feature selection is applied. So after that, the machine learning classifier is applied with a five-fold cross validation. So finally, the performance metrics, accuracy, precision, recall, and F1 score are evaluated for the model. So the slide explains the proposed hybrid gray wolf and whale optimization feature selection strategy. So it is a core contribution of the work. It aims to identify the optimal subset of feature from the high dimensional feature space. So using only relevant features, it improves the classification performance and reduces redundancy. So in this work, we propose a novel sequential meta-heuristic approach. And initially, Gray Wolf algorithm is employed for global exploration of the feature space. So its leadership hierarchy allows the algorithm to efficiently explore multiple candidate feature subsets and avoid premature convergence. So the promising solutions obtained from Gray Wolf optimization are then passed to whale optimization for local exploitation. So these refines the feature subsets using its circular hunting behavior to achieve fine-grained optimization. So by integrating the exploration strength of gray wolf optimization and the whale optimization algorithm, the proposed method ensures a balanced trade-off between global search and local refinement. So it leading to the selection of an optimal feature subset. Next, this slide explains the execution flow of the proposed model. So the optimization process is divided into two sequential phases to enhance the exploration and exploitation. So it is in the sequential form. So in phase one, which covers the iterations 1 to 25. So the maximum iteration I did this of 50 iterations. So for the first of the iteration, I am applying the gray wolf optimizer, and in second of I am applying the whale optimization algorithm. So in phase one, in gray wolf optimizer, the broad exploration of feature space is done. So its objective is to identify promising regions by evaluating multiple candidate feature subsets. So at the midpoint of the optimization process, a transition is occurred. So after the midpoint, the algorithm is switched to whale optimization algorithm. So the final position of the gray wolf optimizer agents representing the promising feature subsets are paused as the initial population for the whale optimization algorithm. So in this,
Gayatri, a quick reminder, you have 2 minutes left with you, okay?
okay.
Yes.
So in whale optimization, it performs the intensive exploitation. So this slide summarizes the simulation parameters used to evaluate the proposed hybrid framework. So to ensure a fair and consistent comparison, the same parameter settings were maintained across Grey Wolf optimizer, whale optimization, and the hybrid Grey Wolf and whale optimization approach. So the population size was set to 20 and the maximum number of iteration was fixed at 50 for all the experiments. The fitness function using optimization was classification accuracy of a random forest classifier. So for random forest, the number of estimator was set to 100, provide a stable and reliable performance evolution. And this slide represents the fitness function used to evaluate the candidate feature subset. So the fitness function is formulated as a weighted combination of classification error and feature subset size. So the first term represents the classification error, which is defined as the 1 minus accuracy, and this ensures it prioritizes the intrusion detection performance. So next, the weighting parameter alpha is set to 0.9. It strongly prioritizes the detection accuracy while still encouraging the selection of smaller feature subset. And finally, this slide represents the selected features, the optimal feature subset, which includes the advertisement message, the scheduling message, data received, and packets sent to base station, and remaining energy. So these features indicate the abnormal node
Gayatri,
behavior.
your voice is cracking a little bit. Please recheck the internet connection.
Okay.
Yes, now it's audible, I think you can do.
Okay. This features contributes the intrusion detection performance, which indicates the abnormal node behavior. So in black hole, gray hole attack, the node will, the attacker floods the network with excessive data packets and they will disrupt the scheduling of the nodes. So these features are represents the and the significance of the features are it the indicator of abnormal traffic behavior. It causes abnormal scheduling plus flooding, and the energy consumption spikes during denial of service attack. So the abnormal packet transmission to base station. So the selecting only 5 feature reduces the dimensionality and faster classification, higher and it yields the higher accuracy, less overfitting. So this is the simulation results. So the hybrid gray wolf and whale optimization with the random forest is compared with the alone meta heuristic algorithm and with the baseline principal component analysis. So it yields a higher performance with the 99.52% in accuracy, precision, recall, and F1 score. So it achieves this higher performance with only 5 features. So next conclusion. So this paper successfully developed a novel hybrid uh, G- gray wolf and whale optimization feature selection framework. So to address the challenge of device detection in wireless sensor network. So it achieves a higher detection accuracy of 99.52% while using only 5 selected features. So demonstrating effective dimensionality reduction. So this improvement highlights the benefit of the transition from exploration, transition of two algorithms, so which enables better feature subset refinement. Overall, the result confirms that the proposed hybrid feature selection strategy significantly enhances the intrusion detection performance. Thank you.
Okay, thank you so much, Gayatri. Sagar sir, do you have any questions?
First of all, I would like to congratulate her for giving a nice presentation with the proper flow of her work. I just want to ask, whatever the results obtained with the help of data set and whatever the feature selection uh, she applied, and whatever the feature selection used by previous researcher, but they have used the same data set, or they have performed the implementation on different data set.
So many existing intrusion detection uses the wireless sensor network dataset only. In addition, some paper utilize the some other data set useful for which is used for IoT related data set. But I choose the first thought with this data set only. In future, I will explore the other data set also. So.
Okay, okay. Because whenever you are going to compare the your work with the help of some other data sets, then you will get the clear idea how the accuracy will vary from data set to data set and all. So it will be clear for you what are the things in front of you, what you have to do for the future. That will be my name for it. Okay.
Okay.
Okay. Okay. That's all.
Okay.
Thank you, sir.
Okay.
Thank you.
Thank you. Thanks, everybody. So now next up we have Nisha ma'am to present her work titled as Cloud Investigation and Response Automation, Cloud Security in the Cloud Era. So Nisha ma'am, are you there?
Yeah, good morning. But my co-author will be presenting. Please
Okay,
allow her to
sure.
share. Yeah,
Yes,
Pranavi. Yeah.
yes. Yes, you can share your screen.
Yeah, please, Pranavi.
Yeah, I hope my screen is visible.
Yes, it is visible. You can begin with the presentation.
Yeah. So, good morning, everyone, respected dignitaries, faculty members, and my fellow participants. I am Pranavi Sodagiri from Symbiosis Center for Information Technology. My co-author Nisha TN and I have developed this paper titled as Cloud Investigation and Response Automation, Cloud Security in the Cloud Era. In this presentation, I will briefly discuss why traditional cloud security is no longer sufficient, how CIRA addresses modern cloud threats, and the key benefits of adopting an automated security framework. Coming to the introduction and background, cloud adoption has rapidly transformed how organizations operate, with more than 60% of the enterprise data which is now stored in cloud environments. While cloud platforms provide scalability and flexibility, they also introduce complex security challenges. Traditional security systems rely heavily on manual monitoring, which is slow and ineffective in dynamic cloud environments. CIRA, the framework that we are talking about right now, addresses these challenges by using AI, ML, and automation to improve threat detection and response. Coming to the drivers for CIRA adoption, cloud environments are highly dynamic with frequent configuration changes that are difficult to track manually. Manual incident detection increases response time and the impact of breaches. Attackers now specifically target cloud native technologies like containers and serverless services. Additional, Additionally, compliance requirements such as GDPR, ISO 27001, and NIST demand rapid and accurate incident reporting, which CIRA enables. Coming to the research objective and significance of the study. Existing challenges. One major challenge is that cloud resources are often short-lived, causing forensic evidence to disappear quickly. Traditional tools generate excessive alerts, leading to alert fatigue among security teams. Organizations also struggle with limited visibility across multiple cloud environments, making investigations and compliance reporting difficult. Our research objectives are a threefold. First, our objective is to examine and analyze how CIRA improves threat detection and incident response effectiveness. Second, it is to analyze the impact of AI and automation on accuracy, response time, and compliance. Third, it is to identify the key deployment and operational factors that influence successful CIRA implementation. A significance of the study is that this study establishes CIRA as a scalable and intelligent cloud security solution. It shows how automation reduces human error and improves response speed. This research also demonstrates how SERA supports proactive security while ensuring compliance with regulatory standards. Literature review. Advancements in cloud security automation. Earlier, security approaches relied on manual log analysis after an attack occurred. Modern cloud security has shifted toward AI-driven automated incident response. Machine learning also helps reduce false positives and improves detection accuracy. SOAR platforms further enhance security by coordinating faster and more efficient responses. Role of SERA in incident response. SERA also enables real-time threat detection and automated containment. Case studies show that organizations using SERA experience significantly reduced response times. The integration of threat intelligence and orchestration tools improve overall resilience against modern cyber attacks. Technological enables for SERA. SERA is powered by AI and machine learning, enabling predictive threat detection and behavioral analysis. Security orchestration tools automate investigation and response workflows. Threat intelligence platform improves situational awareness. Low-code and no-code automation tools increase adaptability and ease of implementation. Coming to our existing research gaps. Despite advancements, several gaps exist in current research. There is a limited real-world validation of SERA across diverse multi-cloud environments. Few studies compare SERA performance with traditional security methods. There is also a minimal focus on human automation, collaboration, privacy, and compliance challenges during automated investigations. So this is an image of our SERA framework. We can see that there are 6 layers, namely detection layer, investigation layer, response layer, integration layer, governance layer, optimization, and learning layer. The ones that are marked in orange are the functionality of the layers, and the ones that are marked in green are the tools that are being used in each of the layers. So we would like to talk about an example, especially focusing on the response layer. So in the response layer, we can see that these 2 tools are used to mitigate risk automatically. For example, let us take a scenario that an organization's cloud server gets infected with malware after a suspicious file is downloaded. So how the layer works step by step is, first an alert gets triggered by Microsoft Sentinel as it detects abnormal behavior, such as unusual outbound traffic, suspicious file execution. Sentinel raises a high severity alert. Playbook activation. The alert automatically triggers Cortex-XOR playbook. No manual intervention is required at this stage. Automated containment immediately isolates the infected cloud instance, blocks malicious IP addresses, disables compromised user credentials. Relevant logs, file hashes, and indicators of compromise are collected. These details are then attached to an incident for forensic analysis. Security teams are then notified via email or dashboard, and Microsoft Sentinel generates a detailed incident report for audit and compliance purposes. This incident data is stored, the response playbook is refined based on the lessons learned. So why is this important? Response time is reduced from hours to seconds, prevents lateral movement of malware, ensures compliance with standards like GDPR, ISO 27001, reduces dependency on manual security operations. Each of the layers have a purpose in this framework. So the detection layer monitors logs and activities in real time. Investigation layer correlates security events automatically to assess severity. The response layers executes immediate containment using automated playbooks. The integration layer ensures seamless communication between the security tools. The governance layer enforces compliance and policy validation, and the optimization and learning layer uses machine learning for continuous improvement. And coming to the cloud threat landscape addressed by SERA, it effectively addresses unauthorized access and suspicious API activities, detects brute force attacks, malware, and cloud misconfigurations. It also manages threats targeting serverless, and containerized environments by reducing false positive. It also helps overcome alert fatigue and compliance risk. So we also have put up a comparison between the traditional security and the SIRA framework. So we can see that there are different aspects such as threat detection, response time, accuracy, scalability, incident handling, compliance management, operational efficiency, and security posture. In the comparison, we got to know that the traditional systems are manual, slow, and prone to human error. They struggle with scalability and proactive threat detection. In contrast, the SIRA framework provides a faster response time, improved accuracy through AI, and adaptive scalability. It also shifts security operations from reactive to proactive threat management. Summary of our findings and the future research directions. Our findings show that traditional security approaches are inadequate for cloud environments. SIRA enables real-time detection and automated response using AI and ML. This six-layer framework ensures comprehensive security and governance. Automation significantly reduces alert fatigue and manual workload. Our future research directions are: we can explore advanced machine learning models for predictive security. SIRA adoption can be expanded across multi-cloud and hybrid infrastructures. Automations can be enhanced to handle zero-day attacks. Greater emphasis is needed on human AI collaboration and security operations. Thank you. We are open for questions, and we believe that SIRA represents the future of cloud security by enabling faster, smarter, and a more resilient incident response.
It was a very interesting presentation. So, Sagar sir, do you have any questions regarding this?
I just want to ask her about the research in cloud and security. So, whatever the researcher got their results in the field of cloud and security. So, whatever the recent fraud occur in various clouds, so in spite of doing so many research on this field, why the things have been happen and how we are going to overcome it.
So, Nisha ma'am, if you want to chime in.
Hello.
Hello.
Yes, sir. So you're
Yes.
asking about how the cloud security is still not
Yes. Yes.
100%. That is what you're asking,
Yes.
sir. Hello.
Hello.
Yeah. Can you repeat the question, please?
I am asking about it.
Uh,
Whatever the different researcher they have
uh,
already worked on cloud and security purposes.
mm,
But in spite of it, still there are some shortcomings. Means
mm,
near about uh, they have got the results up to the 65 to 70%, but still there are 25 to 30 shortcomings are there, 25 to 30% on
mm.
the security issues. So
Yes.
why this happen and what are the remedies to overcome it?
So, sir, one thing what I feel is it is not that the entire what we can say cloud area which we are using in different area. It's not that matured enough. So there are many more updations to be done when if you want it to be very much secure. That is one thing. And obviously, because of the huge amount of data that it is handling, all these uh, all these security solutions uh, are not capable of handling so much of data. So that is one thing. So that is the reason why we are trying to add AI, ML, and all those things to it so that it can handle data more efficiently and detect the attacks faster. That is what I feel.
Okay, okay.
Yeah. Thank you, sir.
Okay, thank you, presenters. So, up next we have Gogula Srilata presenting her paper titled Comparative Evaluation of Deep Learning and Transfer Learning Architectures for Cashew Leaf Disease Detection. So, Gogula Srilata, are you there ready with the presentation?
Yes, I'm ready with my presentation.
Yes, so you can share the screen and begin.
Okay.
You have 10 minutes. You have to
Okay.
wrap up in the 10 minutes.
Okay. Is my screen visible?
Yes, the screen sharing is available, visible. Yes, it is visible. Yes.
Is my screen visible?
Yes, it is visible.
Okay. First of all,
Yes.
good morning, everyone. Where I am Gogla Srilata from Department of Artificial Intelligence and Data Science. Where today I will going to explain our project title, a comparative analysis, comparative evolution of deep learning and transfer learning architecture for cashew leaf disease detection for a detection. Where co-author was a Dr. Silas, he is the supervisor, and this is my agenda today. I am going to explain. Sir, coming to the introduction, where casualty diseases caused a fungal infections, pest, and have a serious impact on crop health, and leading to reduced yields and significant economic losses for farmers. There currently, diseases identification relies on our economic losses for farmers, and currently, diseases identification relies on a manual field inspections and laboratory analysis, where which are a time-consuming, subjective, and impractical for the large-scale orchards. Where due to the challenges, whereas such climate changes, where it reduces the productivity and rapid disease spread, demand fast and accurate solutions. Well, for this, I used AI advances, especially CNN and transfer learning models such as the VGG, ResNet, and EfficientNet, enable the precise detection from the leaves. Where the main objective of this study is to perform a comparative evaluation of deep learning and transfer learning models to identify the most effective architecture for the cashew leaf disease classification, with the aim of supporting the real-time detection and enhancing the precision agriculture. Where this is my next slide, which tells about the overview of the cashew leaf disease. Well, first, in terms of impacts and challenges, cashew leaf diseases significantly reduce the crop yield and directly affect the farmer's income. Where traditional detection methods rely on the visual inspection and laboratory testing, where which are slow and subjective and require a extensive manual effort, making them unsuitable for the large-scale monitoring. And second, the regarding the technological advancements, where recent progress in the deep learning and transfer learning has enabled the automated and accurate disease identification from the leaf images. And the models such as CNN, VGG16, and ResNet 50 and DENS 121 are the capable of learning a complex disease patterns and improving the diagnostic reliability. And finally, our study approach and benefits focus on carefully data set preparation, then model training and evaluation using the robust performance metrics, where this helps identify the most efficient model for the real-time disease, monitoring the support precision agriculture and the informed uh, decision making. Where this is the second side, which motivation for the automated detection where it comes from the several practical challenges. Where the firstly, it is a manual inspection is slow, subjective and prone to human error, especially in the large cashew plantations. When in rural areas, the lack of trained plants pathologists further delays disease identification and timely responses. Where secondly, the climate changes, where has accelerated the spread of diseases such as the anthracnose and powdery mildew. And when the detection is delayed, it results in a significant yield loss and reduced the income. Where particularly affected a small and marginal farmers. Where finally, there is a strong need for the automation and the AI-based solutions, where manual monitoring is not scalable and often leads to an extensive pesticides use, causing environment harm, where AI enabled fast and accurate diagnosis for the simple leaf diseases and supporting the precision agriculture and the sustainable farming. Where this is a related work which reviews key studies and how the our results related to them. The first is the previous work by the Mohanty et and Ferentius shows that CNN models outperformed traditional machine learning for the plant disease detection. In our experiments, while the custom CNN performed well and transfer learning models achieved a clearly supervisor results on the cashew leaf diseases. Where second author, which is Hongo, demonstrates the strength of the dense net through the efficient features reuse and high accuracy, which is a high accuracy in the image classification, and which is a consistent with our findings, where DenseNet 121 shows a strong and stable performance. We're coming to another author, it is a Tan and Lee, reported that efficient net performs so effectively on smaller datasets, and we observed the same in our study. Where survey results in Algebraic uh, Algebraic supports that the transfer learning outperforms a classical CNNs when the data is limited. And finally, while Jayaprakash focused mainly on the anthronodes detection, and our work extends this evaluating the multiple architectures, offering the broader applicability. Where this is the details about my dataset, where we use the cashew leaves healthy and anthracnose infected dataset from the Kaggle, where it is published in 2023. And the dataset contains over 600 RGB images. Evenly, it is split into healthy and infected classes. And the images were resized into a 224 and 224 pixels, where and also the data was splitted into a 70% training, 20% validation, and 10% of testing. Where it is followed, this is my proposed methodology, where this slides illustrates the methodology followed in our study using the pyramid flows. The first, at the base, we perform a problem understanding where the cashew leaf images are analyzed to identify and disease symptoms and define the classification task as a healthy or anthracnose infected. The next, it is a data preparation where images are organized, resized, and normalized to ensure the consistency for the deep learning models. With the third step is the data augmentation. Techniques such as the rotating, flipping, zooming, and the brightness adjustments are applied to increase the diversity and reduce the overfitting. And then a baseline CNN and the multiple transfer learning models are trained. Finally, models are evaluated using the accuracy and F1 score, with the best performing model selected for the real world development. Well, these are the results, overall results and key findings of my experiment, where one of the most important observation is the effect of the threshold tuning, where thresholding significantly improved the model reliability by the reducing the false negatives, especially in the CNN and the DenseNet 121 models. This is a crucial because a false negatives means infected the leaves are missed, where which are caused a rapid spread. And then looking to the performance metrics, the CNN model's F1 score improved from a 0.91 to 0.95, which after the threshold tuning, it indicating a better balance between the precision and the recall. And coming to another efficient net B0 and DenseNet 121 maintained a strong and the stable F1 scores of a 0.97 for both before and after threshold. And most importantly, the inspection V3 achieved a highest F1 score of the 0.98 and accuracy of 98.32. Now that we seen the overall results, let me explain which model performs the best and the why. Where this slides explains why inspection V3 is the best performing model, where it achieved the highest accuracy of 98.32% and F1 score of 0.98. among all the evaluated models, where its strength come from the unique architecture with a parallel convolutional path, where which enables the effective learning of a multi-scale diseases
Gogula,
pattern.
just a reminder, you will have to wrap up in 1 minute.
Okay, fine. Where it is a where unlike the baseline CNN, the inspection V3 maintains a high precision and the recall even without the aggressive threshold tuning. Where this is a class-wise performance summary which detail analysis of the performance across the different classes. And this is a slide which explains the accuracy before and the versus of after the thresholding, where in this inspection V3 achieved a high accuracy before the post thresholding and after thresholding. And these are the key insights which tells about the model performance highlights and the impacts of the thresholding and stability and generalizing the data strategies and the applications of in agriculture which enhanced with the diseases management and advanced monitoring techniques and the precision and the research importance. This is my conclusion, which I say that to conclude, this study shows that the transfer learning models consistently outperformed the baseline CNN for the cash relief diseases, where the threshold optimization improved the CNN's F1 score and the reduced the false negatives. Where among all the models that infection V3 achieved the highest accuracy of the 98% and the best class wise F1 scores and making it the most effective model. Overall, the results confirm that the deep transfer learning provides a robust and reliable solution for the real world. Where this is my future enhancement that where we plan to expand the data set, include the additional cashew diseases and different varieties, and the real field capture images to improve the generalization. And also, I want to use the different models to ensure that. Well, thank you.
Okay, thank you so much, Gogula. Sir, do you have any questions?
Presentation, the way of presentation, the content of presentation, really very good and very systematically arrange all the things in very short duration of time. So, and it's a need of ours, whatever the agriculture field. So, really nice work you have done. Just want to suggest you, whatever the database you have used, just try the same work on the different data set, and if possible, you can integrate those databases so that the volume of data will be more, and you can apply the various algorithms, whatever the feature selections you have done, so that you can conclude on it whenever the data is more and various data is integrated, then what will be the effect on your research in terms of accuracy, in terms of F1 score and all. So thank you.
Thank you.
Okay, thank you so much, Gogula. Now, our next presenter is Miran Firdausi, who will be discussing their paper titled Dev AI, Multi-Agent Copilot for Intelligent Assistance in Software Development Life Cycle. So, Miran, are you ready?
Yes, ma'am.
Yes,
Just
so
give me a
you
second.
can begin the presentation. Please try to wrap up in 10 minutes, everybody.
Is my screen visible?
Yes, it is visible.
Okay. So, morning, everyone. My name is Miran from Symbiosis Institute of Technology, and today I'm presenting the project title Dev AI, a multi-agent co-pilot for intelligent assistant in the software development lifecycle. So let's start with the motivation. What led to Dev AI? Software development today is increasingly complex and involves multiple interconnected stages such as requirement analysis, system design, coding, testing, UI development, and deployment. Although LLMs and AI-assisted tools like code copilots have improved developer productivity, they still operate in a fragmented manner. Most tools focus only on specific tasks, such as code completion or solving bugs. As a result, developers are required to constantly switch between tools and repeatedly provide context at every stages. This repetitive orchestration increases cognitive load, slows down development cycles, and introduces inconsistencies across the SDLC. These challenges motivated us to explore a more unified and intelligent approach to software development. With the rapid increase in intelligence and reasoning capabilities of LLMs, a strong motivating potential has emerged to think how software solutions are created. Model LLMs are no longer limited to assisting technical experts. They are increasingly capable of understanding intent, context, and high level problem description, expressing in natural language. This creates an opportunity to bridge the long standing gap between technical and non technical users by enabling individuals without programming expertise to articulate their ideas in plain language and have intelligent systems translate those intentions into functional software solutions. So we began the literature survey, reviewing more than 30 papers across software development and multi-agent architecture. We observed that recent research in AI-assisted software development focus on areas such as automated code generation and test case synthesis and documentation. And multi-agent systems have also been explored to improve collaboration between AI. However, existing systems and AI-powered IDs still lack awareness of complete SDLC. They provide assistance mainly during the coding phase and limited support for requirement analysis, architecture planning, and deployment. This reveals a clear research gap, the absence of an end-to-end intelligent system that can coordinate all stages of software development in a structured and contextual manner. So we tried asking a simple question. Instead of manually coding every component, could developers describe what they want to build and allow intelligent systems to handle the execution while maintaining human supervision? So these are the objectives of our research. To create an intelligent co-pilot that assists throughout the software development lifecycle, integrate a multi-agent LLMs for coordinated task execution, enable rapid MVP creation through AI-driven prototyping, reduce developer effort through automation, ensure quality with automated testing and validation, support human-in-the-loop supervision for reliability, convert sketches and ideas directly into functional UIs, and streamline deployment with minimal manual intervention. So the proposed solution is a hierarchical multi-agent architecture, and it is a stage-based SDLC workflow with human-in-the-loop validation. So DevAI is proposed to address this challenge. Uh, it is made not to replace developer. Instead, it works alongside them by automating repetitive tasks while keeping humans in control of critical decision. The system progresses through structured SDLC stages such as ideation, planning, development, testing, and deployment, ensuring a smooth and organized workflow. So the agent architecture is like this. There is a central master agent which coordinates all of the tasks delegated to it, and it delegates the individual tasks to the sub agents, which are planning agent, designing agent, development agent, testing agent, and deployment agent. All of these tasks are moved throughout the SDLC stages in an incremental manner, and these are bi-directional. So if a user wants to switch to a previous stage, they can also do it, and it ensures that the state of the project is persisted throughout the life cycle of SDLC. So this is how it moves throughout the stages, from idea refinement to designing, then development, then testing, and finally deployment. And after deployment, the project is completed, and we can again follow this same loop. Next, we are going to talk about how UI generation pipeline works. So in the system, we allow the user to upload a sketch. So sketch can be a hand-drawn sketch, and in which the user can articulate their idea, how they want the solution to look like. The system identifies labels on the sketches and creates a solution which resembles that sketch. So we follow a structured approach where user provides a UI sketch, and YOLO detects the elements in the uh, image of website uploaded by the user. And then those information is passed to the LLM. LLM interprets those instructions and create the final UI. Next, we are going to talk about the method evaluation. So evaluating DevAI requires more than measuring code output. Since this is a developer-facing process-oriented system, we adopted a dual evaluation strategy, combining quantitative and qualitative measures. So these are the metrics on which we evaluated the system. So these are Google Lighthouse scores, which assesses how the website is performing. So it takes performance, accessibility, best practices, and SEO together with qualitative metrics such as a scale of 1 to 5 to describe the satisfaction level and feature requirements. So we can see the clear comparison. In many ways, we can see DevAI outperforms existing tools, and these are the results. Next, we're going to talk about how it works and the final results and analysis. So user can intent their ideas through a natural language way in a chatbot. The chatbot receives the instructions and starts working on it in a background. See, as you can see that in the image, we requested a creation of a website for the project, and the background, the agent takes the request and delegates specific tasks to create those websites. So all of those user requests are turned into agent task, and agent performs those tasks and finally results in a output which looks like our deployed URL. On those deployed URL, we can see our final deployed result. Next, we're going to talk about limitation and futures work. So despite its strength, DevAI has certain limitation. Handling very large or highly complex code bases can introduce computational overhead. Complex business logic and domain-specific requirement may still require manual intervention. Additionally, the accuracy of output depends on the quality of user input and design sketches. Highlight areas for further optimization. In conclusion, DevAI presents a multi-agent copilot that delivers contextual intelligence across the entire SDLC by unifying stages such as requirement refinement, architecture planning, code generation, testing, and deployment. It establishes a coherent and adaptive workflow built on a human-in-the-loop framework. DevAI preserves developer oversight while automating repetitive and time-intensive operations, thereby amplifying productivity without diminishing creative control. So, thank you. Questions are welcome. Hello.
Yes, thank you so much, Miran. Sagar sir, do you have something to say on this? Okay, I think we should proceed to the next presentation.
Okay.
Okay, so next we have Rihanna Neto to present her work titled Edge-Driven Malware Detection in IOMT Using Cognitive Shadows and Federated Learning. So, Rihanna, are you there
Yes.
in the meeting? Yes.
Yes.
You can start your presentation. Yes.
I hope my screen is visible.
Yes, it is visible.
So good morning, everybody. I am Rihanna, and I'm here to present about our paper, which is Edge-Driven Malware Detection in IOMT devices using cognitive digital shadows and federated learning. So first, let's go into IOMT devices. These are basically Internet of Medical Things. So these are devices that are usually in the edge of a hospital network. It can be cameras, it can be monitors, it can be pagers, and many more. So these IoT devices, they're very small and resource constrained, and they also lack a lot of these security protocols, which is why they become very vulnerable to a lot of these malware attacks. So our key goals include having device-specific behavior through CDS. So CDS is cognitive digital shadows. So a digital twin is like a remodeling of the actual IOMT device. But here we're doing a digital shadow where we're only taking care of the most important features that make the device what the device does, essentially. And we're trying to create a lightweight framework and we're using federated learning. So this is instead of sending raw data, we're only going to send the learned parameters of the model. So that way privacy is secure. So our primary targets is ARP spoofing. So ARP spoofing is when a person is pretending to be someone they're not. So a fake IP address would be considered. Then you have denial of service. This is when the network is overloaded. So there's so many packets being sent continuously, it kind of breaks the network. Then you have port scans. This is when they're scanning for open ports, and this is usually done before a bigger attack is performed. So that is our proposed solution to make it lightweight, privacy preserving, and detecting your malware. So in this image below, we can see the devices. So these 6 devices are the ones that we've chosen. We haven't included SyncCall, but the other devices are what is essentially our client devices. So let's jump into the architecture. So first we have a CDS. So we're going to, so we have a profiling data set that we had, and we take that profiling data set and kind of model the device. So we're going to tell that this is the normal baseline behavior. Then we also had an attack data set, which had the different kinds of attacks and the benign mode of a network. And using those two, we come up with how different it is from the normal baseline behavior, and we can get anomaly scores along with that. So now we have our features and we have anomaly scores added into that feature data set. That is what is going to be sent into our XGBoost classifier. So XGBoost is basically like a fast predictor. It is going to give us XGBoost probabilities plus the CDS score. So XGBoost probability is like a probability score. It's like a likelihood of how what kind of attack it's going to be. And that is going to be sent into your PyTorch neural network. So this is a lightweight PyTorch. It's not a very complex convoluted neural network. And using this probability from the XGBoost and anomaly score, it's going to try to find any nonlinear relationship that exists. And now this is all, so this was basically per client, and we use 6 clients. So this stack that you see is per client. Now each of these individual clients is going to send their individual model weights from the PyTorch neural network. And that is going to go into the federated learning server. So instead of sending actual raw data, we're only sending the model weights. So this is how the privacy is preserved. Now the federated server is going to take each of these individual model weights and is going to learn from those model weights and give a global model weight. And the strategy that we have incorporated is Fed average. It's a built-in strategy. Now, these global model weights that we get is going to be sent back to the PyTorch neural networks for each of the individual local clients. So that way, now the local clients can know, okay, this is how a attack is generally happening. These are the network parameters in a general way, and then it kind of fine tunes their network, their local model weights. And retraining happens like this. And also, we also check the global accuracy that the model gives. Now, if the global accuracy is too much, it means that the model might most likely be overfitting. So now you're with the threshold values that we use to calculate the anomaly scores is going to be increased to make it a little more stricter. That way, it gives us a better performing model. And if it's a lesser accuracy, it means it's not catching enough of the malware. So we're going to make the accuracy, the threshold values lesser, a little less stricter, so it can catch more malware. And so if we check the implementation, so first we had dataset preprocessing. So the dataset that we used was CIC IOMT dataset. It's from a Canadian Institute of Cybersecurity. And we did the proper data cleaning, handling missing values, and feature scaling, and min-max normalization, and also the labels of each of the attacks. We converted them to numeric scoring to make it easier for training. And then next we had the CDS integration, where you had the baseline behavior and the anomalous behavior, and we're calculating a CDS score based on that. Then we have the local model training. This is the XGBoost and the PyTorch neural networks. Both so PyTorch we have also ensured is going to be lightweight. And then these model weights, each of the local model weights is then sent to your global server. And this is the global server, and that is what is going to perform Fed average and give us a global model weight. So on the client side, we're going to get a majority vote between the XGBoost and PyTorch, and that is going to be your final prediction of what kind of malware it is. So if we come to the results and discussion, we did 3 rounds of federated learning, and over the 3 rounds, the accuracy increased and the loss also decreased. So each of the local model weights gets a global weight and then fine tunes based on that global weight. Now, if you look at individual XGBoost gave us a 98% accuracy, PyTorch gave 77. So the overall model accuracy was 97. So the overall model accuracy was around 98-ish. And yeah, so then we have the precision, which was around 99, recall was 898, and the F1 score was also 99. So now to include a little more explainability, we also wanted to check which were the features that was used the most from our dataset. And we realized that FIN flag number was what was used the most. And we also had acknowledgement counts. So for ARP spoofing, ARP protocol type, it would check. For DOS, it would check the number of packets which is being sent. For port scan, it would check the size of the packet. So the size of the packet is very small. It's not carrying much information and it would be flagged as a port scan. And finally, when we're coming to the application, it can be used in securing a lot of these IOMT devices used in the hospitals because they don't have a lot of security incorporated into these devices. And then you can also, for these medical devices, you can do behavioral profiling using the CDS. So you know how the normal behavior is and you can flag any deviation from the normal behavior. And because of that, zero-day attacks can also be detected. And zero-day attack is a new attack that has not been seen before. So if there is any anomaly, it can alert, and then with human intervention, you can detect, check, and confirm whether or not it's an actual malware attack. So to conclude, we wanted to give an adaptable, lightweight framework for malware detection in IOMT devices, and we combined cognitive digital shadows and federated learning. And federated learning was incorporated for privacy, preserving, and getting a better accuracy in our model. So future frameworks can include, we can integrate deep learning models, but again, this would not make it lightweight anymore. And you can also use different federated optimization techniques to get better results and also implement cross-device trust scoring. These are my references and thank you.
And thank you so much, Rihanna. Sagar sir, do you have any questions regarding this? Okay, so we'll move on to the next presentation. Up next, we have Bhupendra Fatania to present their paper titled Implementation of a Reconfigurable ALU for FPGA using Partial Reconfiguration. So, Bhupendra sir, are you there?
Yes, madam. Yes, ma'am.
Yes, so you can present your screen and start your presentation.
Ma'am, my screen is visible?
Yes, it is visible.
Okay, so my paper ID is 759 and my topic, my paper implementation of reconfigurable ALU for FPGA using partial reconfiguration. Myself, Bhupendra Fatania, and my co-author is Selsa. So we'll be presenting on the reconfigurable ALU using partial reconfiguration.
So yeah, myself Shail Shah, and today we are going to have a presentation on a paper named as Partial Implementation of Reconfigurable ALU. So these are the outlines of it. So first of all, we will begin from the introduction, then motivation and problem definition. We will go to objective literature survey I have carried out of some papers, then methodology, proposed design, results and discussions, and last conclusion and references. So
Okay, so
first,
just keep in mind you have 10 minutes, okay?
Yes, madam. Yes.
Yes, yes.
So, reconfigurable logic block is a key component in FPGA architecture that enables the flexible hardware implementation. So, it allows for optimizing area, power, and speed based on the application needs. So, basically, I have implemented it in the Verilog that ensures the efficient hardware description and synthesis for FPGA deployment. So, it focuses on the logic versatility, supporting multiple functions within a single hardware block. So this project includes the RTL design, simulation, synthesis, and FPGA implementation. So basically, the motive is to minimize the power consumption, reducing resource utilization, and maintaining performance. So first of all, what is reconfigurable logic block? So it is a basic computing unit in FPGA. It implements the logic functions using lookup tables. It contains flip-flops, multiplexers, and configurable switches. It is programmable, so we can reconfigure it as and when required to change the functionality. So it is designed for power, area, and speed optimization. It supports the parallel processing also. So what is partial reconfiguration? So it is basically it allows the updating specific FPGA regions without affecting the rest of the design. So if we want to change the functionality, then we did not have to change the whole block, and we have to change some of the functionality of it in order to have the new addition of the design. So basically, it reduces the downtime by modifying only selected logic blocks while the rest of the design remains the same. So it helps optimizing the power consumptions. It requires a PR bit stream, which reconfigures only the targeted module. It is supported by the tools like Xilinx Vivado PR Flow and Intel PR Flow. It is used in applications like real-time processing, adaptive computing, and hardware acceleration. So what is the motivation behind it? So it improves the FPGA efficiency by while optimizing the area, power, and speed of the FPGA logic blocks. It enhances the reconfigurability. It reduces the hardware cost as it minimizes the number of gates while maintaining the performance. It increases the speed and it optimizes the power consumption. So this is the problem definition. This paper addresses the higher area and power consumption of traditional fixed hardware ALUs by proposing a runtime reconfigurable ALU using FPGA partial reconfiguration. So the objective is to design and implement a RLB for FPGA using the Verilog language. So it optimizes the area, power, and speed, and it enables the partial reconfiguration to allow the dynamic function changes without reloading the entire FPGA. So this is the literature survey. So I have included some papers in it. And this is the conventional ALU. So static architecture, it includes all the functional units, adder, subtractor, multiplier, and are implemented and permanently reside in the hardware regardless of their usage during operations. So it have the high resource utilization. Power is also high as all the blocks are active at a time, and it is limited flexibility is there. So methodology, what I have designed is it designed with static region and the reconfigurable region. So I have implemented the adder, multiplier, shifter, and logic operations as reconfigurable modules. So followed by hierarchical Verilog RTL design with defined control signals for dynamic operation switching, and perform the synthesis for all the modules and integrated all on the top level PR aware architecture for seamless reconfiguration. So created the reconfigure partition using Vivado 2023.2. Executed the whole PR flow, generated full and partial bit streams for runtime switching via ICAP, internal configuration access port, verified the functionality using the simulations, and evaluated the performance based on resource utilizations and power consumptions, and compared with the conventional static ALU. So this is the implementation of it. So basically there are two types of blocks, static and reconfigurable. So static block is always present, which includes the subtractor and comparator, and reconfigurable blocks that is dynamically loaded during the execution. So there are four reconfigurable blocks. First is adder, which includes ripple carry adder, carry look ahead, and carry select adders. Similarly, there are a multiplier, PR2, PR3 shifting operations, and PR4 logic gates. So this is the synthesis of the project that I have carried out in Vivado tool. So this is the adder, PR1 adder block, which includes, as we can see, there are three blocks inside it, CLA, CS, and RCA. So at a time, only one can be selected using opcode. So there is a
Bhupendra sir, your screen is not moving. Like, the slides are not moving. It is still on the introduction page.
Okay, yes. Okay, let me reshare the screen again, madam.
Yes. Yes, now it is visible.
Okay.
You can continue.
Okay, I think right now though I am on the slide PR1 adder block. Is it visible to you, madam?
Yes, it is visible.
Okay, PR1 adder block.
So yeah, basically we can see there are two inputs A and B, and dependent on the mode 0, 1, 2, we can select one out of it. So we are getting the some output as we can see that 7 and 8 is 15. So we are getting the some output as 0F. Then this is a difference which we have to use when it is written here. So if we want the speed the fastest, then we can use CLA. If we have to get the area utilization, so we have to list area utilization, then we can use RCA, and so on and so forth. So this is the multiplier block. Similarly, as I have discussed in the adder block, there are three multipliers: array, booth, and Wallace tree multipliers. This is the simulation I have carried out. That is, there are two inputs, mode and product. So 3 and 2, we are getting 6 output multiplication. Then this is the difference between them.
Madam, screen is visible. It is changing. Hello, ma'am.
Yes, it is on the PR1 adder block
Okay,
simulation.
okay. Let me stop this sharing and let me recheck again.
Yes, you have to share the entire screen,
Yes,
not
ma'am.
a specific window. Yes.
Can you check whether the screen is changing or not, madam?
Yes, it is changing now. Yes.
So, shall I start with the beginning or?
No, you start with where you left.
Okay, okay, ma'am. So I think we are discussing about this PR1 header block, and these are the results.
Yes.
And this is the difference between the RCA, CLA, and CSA. So if we want speed as the fastest, then we have to use CLA. And area utilization, if we want least, then we have to use RCA. And if we want low power, then we have to use RCA in the same way. So this is the PR2 multiplier block. So we are getting 3 out of it: array, booth, and WTM multiplier. So at a time we have to select any one based on the opcode. This is the simulation result of it, multiplier block. Then there is a difference between wireless, array, both, and booth and array multiplier. So if we want low delay, then we have to use WTM multiplier. If we want the fastest speed, then also we have to use WTM. If we want area utilization, then we can use both WTM booth multiplier. And if we want the power consumption low, then we have to use booth multiplier. And this is the third PR block, this shifter block. So basically, this is the simulation result of it. This is the fourth PR block, logic gates block. So 6 logic gates are implemented, and this is the simulation results of it. Then this is the proposed design. So here we can see that there are 4 blocks: PR1, PR2, PR3, and PR4. So basically, these are the reconfigurable. So we have in that 3 PR adder is included in one block. Basically, there are static blocks also included in the design. So we are getting subtractor and comparator into it. So yeah, this is the synthesis results and from the Vivado tool. So there are 4 PR1, PR2, PR3, and PR4 blocks in it. And at a time, only one block will be selected from these 4. And there are static blocks available at all time, that is subtractor and comparator. So we are getting the output. We are getting the same output at a time. So this is the simulation results. I have integrated all the results which I have discussed later. So here we can see there are 2 2 inputs in adder, and based on the mode we are getting the output of it. Then 2 multiplier inputs based on the mode, and we are getting the product. Then shifting operations. There are 6 shifting operations are performed, and then this is the simulation results of the static blocks, subtractor and comparator. So for A, B, subtractor, so basically A minus 6, that is 10 minus 6, we are getting the result 4 difference. And 6 minus A, we are getting borrow out as 1, and we are getting the result 6, C. And the comparator block is there, 2 inputs. So 7, 7, we are getting equal flag as high. 9, 4, A is greater than B, so we are getting greater than flag high. And A is less than B, so we are getting that flag low. So basically, this is the power analysis. So basically, without PR, we are getting dynamic as 17.695. So it is the power. So we are getting high power as compared to the PR. After enabling the PR flow, we are getting 9.657 watt. So it is drastically reducing by 45%. And static power is same as it is available at all time. So we are not getting low static power because it is available, and we are getting only the dynamic power is changing from 17.695 watt to 9.657. So basically it is reducing drastically. And similarly, resource utilization report is also there. So we are input output pin, as we can see, without PR there is 43% input output pin is used, and with PR it is only 15%. So there
Sir, you have 2 minutes with you remaining.
yeah. So with PR also, with PR we are getting low input output pin, so area usage is low. So these are the comparison results. So without PR, this is the power 17.695. So it is reduced drastically 9.657, and utilization comparison is also there. So basically, this is the results and discussion. So I have successfully implemented a runtime reconfigurable ALU using FPGA partial reconfiguration flow, achieved significant area reduction by reusing the same hardware region for multiple ALU functions, observed low dynamic power consumption compared to conventional fixed function ALU, and verified the correct functionality of all reconfigurable modules through simulations. Resource utilization, power, and power reports are confirmed improved efficiency of the PR based design. So what is the conclusion? As I have concluded earlier, that it is 42% we are getting low resource utilization as compared to the without doing PR flow. After doing the PR, we can reduce the resource utilization to 42%. Similarly, in low power consumption, we also we are getting 45% decrease in the power consumption after performing the PR flow. So, and modular and scalable architecture. So by partitioning ALU into static and reconfigurable regions, the design offers high flexibility, allowing new functions to be integrated without overhauling the entire system. So the future work is we can enhance the reconfigurable ALU can be enhanced to support more complex operations like division, modulo, and floating point calculation. It can also be adapted for specialized tasks such as AI processing, image manipulation, and cryptographic functions. Real-time dynamic reconfiguration could allow the ALU to change its functionality on the fly based on system needs, and fault-tolerant designs could improve reliability for critical applications. So these improvements would make the ALU more versatile and suitable for a wide range of modern computing systems. So these are the references I have taken. Thank you, ma'am.
Any question, madam?
Yes, Sagar sir, do we have any questions regarding this? Okay, so I think he has no questions regarding this.
Okay, madam. So thank you, madam, and for allowing for presenting the paper in the conference, madam.
Yes, sure, it was a very interesting paper.
Thank you, madam.
Yes. So next we have Santosh Kumar S to present their work titled as Intelligent Pattern Recognition Using Automated Image Analysis with Deep Convolutional Networks. So, Santosh, are you ready?
Yes, ma'am.
Okay, so you can present your screen.
Ma'am, is my screen is visible?
Yes, it is visible. You can begin. You have 10 minutes.
Yeah, thank you, ma'am.
Yes.
Yes, good morning, everyone. I am Santosh Kumar, and today I am going to present my research work on intelligent pattern recognition using automated image analysis with the deep convolutional neural networks. This paper focuses on how deep learning can automatically learn meaningful patterns from images and overcome the limitations of traditional image analysis methods. These are the contents we are going to explore in today's session. Let's see one by one. At first, abstract. Here, image pattern recognition has always been challenging, especially when using traditional approaches. Most classical methods depending on manual feature extraction, which requires both domain expertise and does not scale well. So in this work, we use deep convolutional neural networks, which can automatically learn features directly from images. We tested our model on MNIST or Cypher 10 and medical image datasets. The results show high accuracy and strong robustness, making the system suitable for real-world applications such as healthcare and security. Next, introduction. Here, today, massive amounts of image data are generated in areas like healthcare, security, and remote sensing regions. Traditional pattern recognition techniques rely on handcrafting features. These approaches are rigid and struggle when image conditions change, such as lighting, noise, or scale of the image. Deep learning changes this completely. CNN can learn important visual patterns directly from raw images without manual reinventations. This paper focuses on building an intelligent CNN-based system for accurate and automated image pattern recognition. Now let's see problem definition. Let's clarify the problems. Traditional image analysis methods require manual feature extractions. As previously said, these are time consuming and are sensitive to noise and image variations. Because of this, they perform poorly on complex and diverse datasets. For existing systems also fails to generalize well across different image domains. So there is a clear need for automated, accurate, and robust pattern recognition systems. For this problem, we proposed our work that is an intelligent pattern recognition system using deep CNNs. This deep CNNs includes automatically extracts meaningful features from the raw images, avoid handcrafted feature designs, and train and evaluate the model on multiple data sets. So we aim to improve both accuracy and robustness when compared to traditional machine learning approaches. Now let's see the methodology and implementation. Here I'll briefly explain how system works. First, input images are pre-processed by resizing and normalizing them to ensure consistent training. Next, we Next, we use multiple CNN layers that consisting of convolutional layers, RELU, which stand for rectified linear unit activation, and one more is max pooling layer for dimensional reduction. The model is trained using Adam optimizer and cross entropy loss function. Performance is evaluated using accuracy, precision, recall, and F1 score. Here we can see in the diagram, at a high level, the CNN learns how low-level features like edges in early layers and more complex patterns in deeper layers. This hierarchical learning allows the system to recognize different image patterns effectively without manual tuning. The entire pipeline is end-to-end connected and fully automated. This figure shows the overall system architecture. Images go through pre-processing, followed by CNN-based feature extraction. The learned features are then passed to the classifiers for final predictions. This architecture ensures both efficiency and robustness across the different image types. Coming to the results and discussion, here the proposed CNN model achieved high accuracy across all tested datasets. When compared with traditional methods such as support vector machines and shallow neural networks, our model performed significantly better. Even under noisy and varied input conditions, the CNN remained stable and reliable. This confirms that automated feature learning improves pattern recognition performance. The improvements are consistent across datasets, here showing that the model generalizes well. This makes the system suitable for real-world scenarios where image conditions are unpredictable. You can observe the high accuracy, precision, recall, and F1 score values across different pattern categories here in this table. Overall, the results clearly validate the effectiveness of proposed CNN-based approach. Coming to the conclusion, here, to conclude, the proposed CNN-based system significantly improves image pattern recognition accuracy, automatic feature extraction removes the need for manual feature design, and the system is robust and adaptable across the datasets. In future, we are planning to optimize the model for real-time applications and scale it for large-scale and embedded deployments. These are some possible references we took from past authors. Thank you.
Thank you so much, Santosh, for presenting your work. So I'll
Thank
ask
you.
Sagar sir if you have any questions, or we'll move on to the
Santoshi,
next presentation. Yes.
hello.
Yes,
Yes,
sir.
sir.
Santoshi, I just want to know whatever the statistical analysis you have done in terms of table.
Yes,
So it
sir.
shows that accuracy for the handwritten is more as compared to texture. Okay. So first of all, why is it so? And second thing, whatever the references you have used
Yes,
that are
sir.
from 2014 2015, have you referred any research, any latest research on the same topic, which covered the years from 2023, 24, 25?
No, sir. We considered only we were below the 2015, sir.
Your voice is not audible.
Hello?
Yes, yes, you can
Your
speak.
voice is not audible. Please say.
No, sir. Hello?
Hello. Yes.
Yes, sir. We took references from uh, past years below the 2025, sir. 25 only, sir. We considered most papers below 2022 more, sir. Recent
Okay.
researchers also has variations, sir, compared to traditional models. So we consider below years only compared to recent researchers.
Okay.
Okay, so let's move on to the next presentation. Our next presenter is Vivek, who is discussing his research paper titled as Neural Network Compression, Methods, Metrics, Applications, and Challenges. So, Vivek, you can share the screen and start with the
Yes.
presentation.
Sure.
Yes.
Yes. Is it visible?
Yes, it is visible. You can begin. You have 10 minutes.
Okay, thank you. Good morning, everyone. My name is Vivek. I'm a research scholar at RB College of Engineering. This work is co-authored by me and my guide, Dr. Rajashri Shettar. Today, I'll be talking about neural network compression, that is compressing large-scale neural networks, especially tailored for the edge devices. So, the introduction. Next generation devices require real time multimodal understanding, not only a single modality that we have, like language, but it also requires vision, language, and many other modalities such as audio also. Cloud based multimodal AI faces latency, internet dependency, and privacy risk. Foundation scale multimodal models exist, but they're too large and power hungry for mobile deployment. On device multimodal AI, it enables private, offline, low latency perception and interaction. Some of the applications are personal assistance, AR, VR, accessibility, and robotics. This work mainly surveys the state, challenges, and future roadmap for efficient multimodal LLMs on the mobile edge. So some of the previous literature works on this specific topic are here. So the prior surveys, they address a lot of issues. Some of them give a broad review of compression techniques across classical CV models, taxonomies, and automated design, compact, efficient architectures, benchmarking tools for comparing compressors. But they also lack a lot of things. They have a very limited deployment metrics, a weak coverage of LLMs. They are sometimes only technique specific. They're not compression focused. They focus on evaluation tools, not a conceptual taxonomy. Some of the key works in model compression, some of the most basic works in model compression, they mainly start from 2015. Han and others proposed deep compression. It was mainly pruning and quantization pipeline for compact DNNs. Jacob and others proposed integer 8 quantization. It was efficient integer only inference on edge hardware. San and others proposed Distilbert. It was a very efficient technique. Knowledge distillation for efficient NLP models. Shao and others proposed smooth quant, which is the most recent work. It was accurate post-training quantization for LLMs. So as neural networks mature, they keep on getting bigger. The number of parameters are increasing very heavily, and the gap between those and edge devices is also increasing. So that is the motivation behind this work. And compression also enables a real-time inference on edge, lower cost and lower power consumption, improved on-device privacy because it is on the edge, and scalable deployment across a variety of hardware. So the contributions of this work mainly consist of a unified taxonomy covering multiple axes, compression principle, training stage, granularity, and hardware awareness, deployment aware perspective linking algorithms to device constraints, evaluation best practices for latency, memory, and energy reporting, practical guidelines and roadmap for reliable real-world deployment. So we'll move on to the unified taxonomy overview. This is the major contribution of our survey work. They're categorized into four major categories: compression principle, training stage, granularity, and deployment focus. We'll talk about compression principle first. The most major ones are pruning, quantization, knowledge distillation, and architecture design. Pruning is removing redundant weights or neurons. Quantization reduces the precision from floating point 32 integer 8, or it can be 16 also. Knowledge distillation trains a smaller student model from a teacher model. Architecture design. Efficient model design can be done using neural architecture search and such other methods. And training stage. There are three other main variants in training stage also. Pre-training, that is during design, optimizing data, architectures and such. During training, quantization aware training, knowing that we're going to prune or quantize. In knowledge of that, we do it. Post-training, that is after training a neural network or a model, post-training quantization of or fine-tuning is done to optimize those things. Granularity. So this is in again categorized into three streams: fine-grained, structured, and model level. Fine-grained is it's removing individual weights or bits or such things. Structured is removing entire channels, heads, or blocks. Model level is the entire layers and modules. Deployment focus: hardware agnostic and hardware aware. Hardware agnostic is not really much. It doesn't have much knowledge about the hardware. It only sees the model size, flops, and such. Hardware aware, it considers everything: latency, energy, memory, etc. So these form the backbone of modern model compression techniques, that is pruning, quantization, knowledge distillation, and low rank decomposition. What pruning does is it removes redundant weights or channels. Quantization, it lowers numeric precision. Knowledge distillation transfers knowledge from teacher to student, and low rank decomposition factorizes weight matrices. Some of the key advantages of these are reduced compute, smaller memory, and faster integer execution. We can maintain accuracy in compact models, efficient compute with minimal accuracy loss. Some of the best use cases for these are for pruning, for example, is CNNs, transformers on edge devices. Quantization is good for large language model acceleration, for example, real-time deployment on edge devices. Knowledge distillation, it's combined with pruning and quantization, we can get really efficient distilled models. Low rank decomposition can be used in transformers and large adaptable models. And representative, these are some of the results from key compression techniques that we mentioned in our paper. We've discussed these before. Deep compression, it was the data set and the model were AlexNet and ImageNet. Applying these techniques, that is pruning and quantization together, there was a 35 times smaller model, and similar accuracy was retained. Second one is int8 quantization by Jacob and others. The model was MobileNet V2 on ImageNet. The results were 2 to 4 times faster inference with less than or equal to 1% accuracy drop. Distilbert by San and others in 2019. The model was BERT based and the database was Glue. And it also, the results were 40% smaller model, 60% faster, and also retains accuracy. Smooth Quant by Shao and others in 2023. This was the most recent one. And the model was OPT 175B, and it was done on LLM tasks, 6 to 8 bit pre-training quantization, and minimal perplexity degradation. We'll move on to deployment aware compression. This is how we can deploy models on edge hardware. First one is we need to profile the device, layer-wise runtime measurement, per layer latency, memory, and bandwidth. Compression selection, we can select from a variety of methods: pruning, quantization, knowledge distillation, neural architecture search, etc. Third one is the next step, that is fine-tuning. The fourth step is compiler optimizations, because compiler optimizations can go a long way in showcasing how efficient these models can be at the edge. And the last step is validation and monitoring. We can measure various metrics and latencies, throughputs, inference, etc. Some of the evaluation metrics are compression ratio and model size, sparsity level, flops, max reduction, latency and throughput, energy per inference. Task performance metrics are different. Accuracy retention can be measured using top, glue, map, etc. for robustness and stability after compression. Some of the benchmark data sets and evaluation platforms are some of the data sets provision particularly are Cipher, Coco, and for NLP it's Glue and Squad. For multimodal, we can use VQA, MS Coco captions, etc. Evaluation platforms include CPU, GPU, edge accelerators, neural processing units, digital signal processors, etc. Some of the must report metrics are target device plus backend, batch size plus warm up runs, and consistent measurement settings. Now we'll move on to the challenges in model compression that we face today. There's a lack of standardized
You have
cross
1
domain
minute
benchmarks,
left, Vivek.
limited theory on and yes, sure, ma'am. Yeah. So there's limited theory on sparsity and quantization noise. Compression can reduce robustness and privacy guarantees. And still, it's difficult to compress diffusion models, and accuracy efficiency trade offs remain hardware and task dependent. Future directions are automated hardware-aware pipelines for mixed compression, dynamic sparsity, and mixed precision during inference, hybrid core design, combining pruning, quantization, and distillation intelligently. So we'll conclude with this. Neural networks keep scaling while deployment constraints remain. Compression enables efficient, scalable, and practical deep learning at the edge. Hardware-aware compression is essential for real-world deployment. Compression is now a core design principle for edge AI systems. So these are some of the references that we've used, and thank you.
Okay, thank you so much, Vivek. Sagar sir, do you have something to say on this? Okay, so we should move on to the next presentation. So the next presenter is Audrey Erlen A. To present her research paper, Performance Evaluation of Convolutional and Recurrent Neural Networks for Emotion Recognition in Kannada Speech. So are you ready with the presentation, Audrey?
Yeah, I am ready.
Yes, so you can begin the presentation.
Yeah.
Yeah.
Could you please confirm if my screen is visible?
1 second. Yes, it is visible.
Okay. Good morning, everyone. I will be presenting my work titled Performance Evaluation of Convolutional and Recurrent Networks for Emotion Recognition in Kannada Speech, along with my research supervisor, Dr. Chandrasekhar M. Patil, and myself, Audrey Erlin. So, speech emotion recognition is actually a very important part in effective computing and is being used in applications such as healthcare as well as human computer interaction and intelligent assistance. However, these days significant progress have been made and concentrated only in high resource languages such as English, German, Mandarin. Why? Because large set of data set is present in such languages. While coming to low resource language like Kannada, no much progress has been made. So this actually creates a major gap. Low resource languages, which includes Kannada, which has been spoken widely, is left behind due to lack of foundational data sets. Next, moving on, the research gap that we found out or why we started working on this is because it mainly concentrates or focuses on Kannada, which is a Dravidian language which has been spoken by millions of people. The primary challenge here is in any progress of Kannada speech emotion recognition is the absence of high quality annotated emotional speech corpus, which is not available. So without this fundamental resource, developing or evaluating any robust models, deep learning models will not be of much use in this research area. So our contribution in this research, the first contribution would be to create and augment a novel Kannada data set. So build the first Kannada speech emotion data set from scratch and expand it using the state-of-art techniques, which includes the different augmentation techniques like pitch expansion or time stretching or including some noise, Gaussian noise or white noise. So once this is done and the data set has been expanded, a comparative analysis was conducted using two deep learning architectures, which was CNN and RNN on the new data set which was developed. And once this is done, we compared the results of CNN and RNN, and it showed that RNN effectively gives us the more accuracy when compared to CNN because of the temporal dependencies in speech that is present, and such as pitch and frequency. It produces more accuracy when compared to CNN. Next, moving on, how this data set was created. So in order to address the gap, a balanced high quality emotional speech data set was created, which actually had 2,500 total samples, which was recorded from 20 native speakers, which included 10 male and 10 female, and for 5 balanced emotions: anger, happy, sad, fear, and neutral. And 5 native annotators were also included here in order to annotate the speech, and we achieved a kappa value of 0.82, which indicated a excellent score. So once this 2,500 total samples were generated, this was not sufficient to test on the deep learning models. So we had to expand this data set. In order to do that, we used certain data augmentation techniques such as pitch shifting, time stretching, noise injection, spec augment techniques. So in pitch shifting, utterances were shifted by +2 semitones in order to mimic the pitch variations, but the duration was kept constant here. In case of time stretching, speech signals were compressed or expanded from 0.9 times to 1.1 times in order to simulate different speaking rates, but the pitch was kept constant here. And a low level Gaussian noise was also added to the original speech signal. And in case of spec augment, the original signal was not disturbed, but the time and frequency masking were applied directly onto the spectrograms of the speech signals. So when all these methods were done, the original samples that we had, which was around 2,500, was increased to approximately 11,250 samples. So we validated this augmented data set of 11,250, and when only pitch shifting was done, the accuracy was around 75.56, and when spec augment was done, it was 75.2. When time stretching were done, it was 74.8, and when noise injection was done, it was 74.4. But when all the augmentation techniques were combined, it achieved a greater accuracy at 77.1%. This was done as a baseline work, but this was not actually the final accuracy. We also have a slide which shows us the final accuracy later. So this is actually the end-to-end system for Kannada speech emotion recognition, which includes the input speech that is given, and from the audio speech it receives what the pre-processing technique is done and feature is extracted. Then we have the classification, and then the output is generated. So the proposed system follows actually 4 steps here. First one is the MEL frequency septal coefficients are extracted from the augmented data set that we generated. So when MFCCs are extracted, we use 13 coefficients plus delta and delta delta coefficients, which comes up to around 39 features. And we also considered the 0th features. So totally 40 MFCC features are considered. So using these MFCC features, we use CNN and RNN classifiers in order to classify the emotions. So the output would be generated among the 5 emotions like happy, sad, anger, fear, and neutral. So the two architectures that we used were CNN and RNN. So why CNN was used is because it excels at the learning local discriminative patterns from the matrix like data, and it treats the MFCC feature maps as images, learning, and spectral patterns related to different emotions through a series of convolution as well as the pooling layers that is present in the convolution neural network. And why recurrent neural network was used? Because it is specifically designed to model sequential data and temporal dependencies. When we speak about speech data, it is also having certain temporal factors like pitch, frequency, etc. So that is the reason we obtain more accuracy in case of RNN when compared to CNN. And this RNN also processes the sequence of MFCC feature vectors over time using a hidden state in order to maintain context from the previous time steps, which means it retains the previous step results in order to produce the next result. So this slide shows us the overall accuracy, recall, precision, F1 score, kappa value, as well as the MFCC values that was generated for CNN and RNN. So if you observe this table, it clearly states that CNN is getting around 93.75 accuracy, while RNN is 98.84 accuracy. So similarly, for all the parameters, the RNN value is more when compared to CNN. So the RNN achieved a near perfect accuracy of 98.84, substantial improvement over CNN, which is already actually strong with 93.75% of accuracy. So this shows us the confusion matrix for both CNN as well as RNN. The diagonal value gives us the actual value of obtaining the accuracy here. So if you observe here in case of CNN, there are few points of confusion which has not been accurately selected or recognized here. But in case of RNN, if you observe, most of the values are nearing to 100. Just few values in case of fear and anger is being misclassified here. But in case of CNN, there is a lot of misclassification when compared to RNN. And when we speak about the class-wise accuracy as
Audrey,
well,
just a quick reminder, you have 2 minutes remaining.
yeah,
Okay.
sure.
Yeah.
And when speaking about class-wise accuracy as well, when we have 5 different emotions, in all these 5 different emotions, we have RNN outperforming the CNN values. You can see we have 100, 100, and 100 for happiness, sad, and neutral, while in fear and anger, we have around 96 and 98, which is more than the CNN values that have been generated. So what is the takeaways from this research is a foundational resource for Kannada SCR has been established, which means we created and publicly shared the first balanced annotated emotional speech dataset, which consisted of around 11,250 samples because of the augmentation techniques we included. And temporal modeling is also very crucial, which was done by RNN in order to give us the 98.84% of accuracy. And data augmentation is a highly effective strategy for low resource scenarios, which means if data augmentation was not present, it would be difficult for us to implement this SCR using CNN and RNN. So what would be the future work in this part of the researchers to investigate the performance of the state-of-art models like LSTM, GRUs, and attention-based transformer models, which has not been done as of now for Kannada language specifically, and study the potential of fine-tuning large pre-trained models on our Kannada dataset to further boost performance as well as cross-lingual capabilities, and to incorporate more diverse and spontaneous speech samples to improve model robustness in real-world applications. So these are the references that I had considered, and thank you.
Thank you so much, Audrey, for your presentation. I will ask Sagar sir if they have something to say on this presentation, or else we'll move to the next presentation.
Yeah.
Okay, so our next presenter is Tanikela Venkatramanachan, and he is here to present the paper titled Voyage Mate, Revolutionizing IRCTC with Social Authentication, Live Rail Data, and Predictive Recommendations. So, are you ready with the presentation?
Yeah, good morning. Am I available? Am I audible?
Yes, you are audible. You can present your screen.
Just a second. It says you cannot start screen sharing while the other participant is. Okay, right. Sorry. Got it. Yeah, one second. Is it visible?
Yes, it is visible.
Okay, just a second then. So, good morning, everyone. My name is TVR Charan, and I'm one of the authors for writing a conference paper on the project Voyage Mate, Revolutionizing IRCTC with AI, Enhancing Railway Ticketing Through Personalization, Real-Time Intelligence, and Passenger Safety. I'm from the College of CBIT on Hyderabad, and my department is Artificial Intelligence and Data Science. Okay. Right. So, what was our background and motivation for this? When we talk about IRCTC, what is IRCTC? IRCTC is basically Indian Railway Catering and Tourism Corporation. So, if you want to book a train ticket to go to from Hyderabad to Bangalore or Bangalore to Mumbai, you visit this website and you book your ticket and you book your train ticket. So, on paper and on application, it is really powerful. So now when we talk about India as a country, we are the largest country in terms of population, and Indian Railways itself serves 23 million passengers daily. Is our motivation right now, to build a project? Okay, right now there is IRCTC. We want to build a project that completely replaces it. No, over here we are calling out what are the weaknesses of IRCTC, and we have built a project basically to indicate where where we can improve IRCTC as a whole for the users. So as we come to the right now, IRCTC Railway serves 23 million passengers daily, uh, and it is one of the largest ticketing systems. So now, despite digitization, now we are in the world of digitization where we can just do everything by phone. There are still a lot of issues such as long waiting lists and booking failures sometimes, and then there is no personalization. It is like a one-time one-time user experience, as simple as that. Then there will be payment issues, server issues. There'll be a lot of traffic, and then we have safety concerns because when you even book when you're going solo when you're going solo, you will not know whom you're going with. So now, how does our program solve this? So now here we'll focus on what is the problem statement. So basically, problems when we discuss problem statement, we are talking about what is the problem in this in the IRCTC current day. So now the key limitations of the existing IRCTCs are, we can say, that tickets when during peak hours, when we are talking about festivals like Diwali, or when we are talking about Holi, when people travel a lot, when they get holidays from their work, they travel a lot. And during those hours, because of heavy traffic, tickets will get over within seconds. So now when I want to go and book a ticket, I have to click on it. Then if my network is slow, or if I'm not in a proper place, that time the tickets will just vanish. And its next thing is, it's a one size fits all booking experience, meaning that the IRCTC platform will treat everyone as the same. It will not give a personalized experience to you. Then next is now we know about Ask Tisha, which is a chatbot in IRCTC. That is made to essentially help customers. But the problem with that is, again, it is more of a scripted chatbot that only responds to certain questions. It will not interact with a user on a proper level, where on a more personalized level. Because and it becomes a problem for those users who are not, example, very old, or who are not good with technology. Next is, there is no transparency in the seat mate allocations. So now, when I'm booking a ticket, I do not know who's going to be sitting next to me. If I'm traveling solo, supposedly, I do not know who the person next to me will be. This could be majorly a problem for women, or children or young adults who are traveling alone. And then next is the increased complexity with the Aadhaar verification. And now, when we talk about Aadhaar verification, it is definitely very important. But the way the IRCTC platform makes it is, unfortunately, its UI is very complex when we are doing the Aadhaar verification. Now, when we here's the solution to this is VoyageMate, which we designed. So now when we come to VoyageMate, it basically converts the basic login. In login, what do you do for IRCTC? You have to create a username, you have to create a password, and then that's it. Yeah, you will not be able to remember. If you forget your username, again you'll have to go through a long process of recreating a username. Or if you forget a password, then that's a long process of verifying Aadhaar. Over here, we have implemented social authentication, where basically you can sign in with your Gmail or anything like Google, or you can go through Microsoft account or anything, making it more simpler. And now, one may ask the question: how aren't we compromising safety over here? The answer is no. We are still gonna maintain the Aadhaar verification, but the Aadhaar verification over here will be only a one-time process. Unfortunately, the issue with IRCTC is that when you put your username, when you forget your username or password, you'll in the end have to again go back and then verify your Aadhaar details, your PAN details, etc. But over here, Aadhaar verification is a one-time process. Next over here is live train tracking mechanism. Our project over here introduces a way to basically make it more easier for you to track your train. Example, you want to know that you booked a ticket for your train. You want to know where it is. So you can simply put the ID of it, and then ID of your train, and you can lively track its location, which station it has gone to, which station it is right now at, how much longer would I have to wait, etc. Next is the gender-based seatmate allocation. We have introduced the gender-based seatmate allocation, where essentially, whenever you put your gender example as a male or a female, you can get a customized allocation. So basically, there is no threat of ambiguity of when you're traveling alone, who's gonna be my partner? Is it gonna be safe for me? Etc. Etc. This especially is helpful for women who are traveling solo and all. Next is the travel history and personalized train recommendations. Over here through VoyageMate, you can essentially look at your based on your travel history, and you can go to where you have traveled if you are a frequent traveler. And then there is personalized train recommendations, where it'll compare your own journeys with other people's journeys where they have traveled, and it'll create a smart recommendation system for you, which can be toggled on or off as per your convenience. All right, and then next is the GPT-based emergency conversational chatbot. Now, already I have discussed that the IRCTC already has Ask Disha, but the problem with Ask Disha is it's very scripted. So you'll have to you have to prompt the chatbot in a very specific way. You will not be easy for those people who are not exactly good with technology typing. They will have to, again, it's very inconvenient for them to basically get their results which they want. But over here we are using a GPT model, GPT model, which is VoyageMate chatbot, which basically is very fast. It you can prompt it however you want, and you can get whatever the result. You can get the accurate results. Next, let's discuss the system architecture. Now, when it comes to the system architecture, we start with the presentation layer, which is basically the web mobile applications, the social login, which we created. Then after that, when you go to the application layer, we use the GPT chatbot, KNN recommender system, and booking and validation logic. So over here, the KNN recommender system is basically what we are using for the recommendation, for the personalized recommendation of travel trips, trains, which train and all. And you may ask, why use KNN? Why not go for any other powerful deep learning model, or deep learning model? But the problem with the other deep learning models is they are very heavy in architecture, and they will be and they are more complex to set up. KNN relatively is more lightweight. It'll just take basic info of you: what's your name, what's your age, what is your where have you traveled, and using that itself, using a comparison table with other chat with other passengers, it'll generate a powerful recommendation system. Next is the data layer. Data layer is basically where we we set up the passenger profiles, travel history, and then secure transaction records. Now, coming to the workflow of this, over here it starts with the user authentication. He can go for his journey, he can search for his journey, he can we are using a query database, and we are even using IRCTC API over here to basically get the data of trains. Then after that, we have added the recommendation stage, and then a recommendation stage where the KNN will analyze your profile, it'll personalize your suggestions. Then after that, there's the booking stage. You can select your train, and then coming to the 20% blocking. Or basically, what this is this is one of the most powerful innovations in our project. Is basically means that now when you the problem with normal train tickets is when you run your payment, sometimes there will be a payment failure which will cause you a payment failure, or you'll run into some server issue which will cause cause the issue of you losing that seat to another person who has booked it at the same time. So over here, and this happens typically with tatkals and last minute train bookings. Now over here, what we are doing is essentially that you can basically
Just a quick
reserve.
reminder, you have 2 minutes remaining.
Sure. So basically over here you can just you can pay 20% of your you can pay 20% of the cost for your ticket and you can reserve it for a while beforehand itself, so that you can make the full payment at your convenience in a limited time slot. This is basically to ensure that you do not run into issues where like okay, when you're booking in a last minute, or whenever you're booking, if there's a payment failure, and someone will come and steal it. This train ticket reservation is very fast, very quick, just a 20% quick payment, and then your ticket is reserved for a while. Again, supposedly you want to cancel it, you can cancel it, and you'll get a quick refund. Next is seatmate visibility. You can check the gender of the adjacent passengers. This is especially useful for women. If you are women who do not who prefer to choose who prefer to go for more safer seatmates, etc. Then and over here, all the chatbot provides strong assistant when you want. Example, when you want to search your journey, when you want a recommender, or when you want to check the booking stage, or the anything. Now coming to the technology stack which we implemented over here. For the front end, basically for the back end, we used Flask and Django. Basically it handles the service orchestration. Then it basically helps in integrating the KNN modules, and then it manages the APIs and the booking logic. Then within AI ML modules, we are basically using it the GPT model GPT model and then the KNN for personal recommendations, and then real time and yeah. Coming to the front end, we are relying on React for the web applications, and Flutter for the mobile applications, because since they are more simpler to use, and they are responsive and user friendly. Now the biggest question for you people must be, how are you protecting your data? Is your data going to be secure? Now, to ensure that again, during the login itself, we are ensuring that we are doing an Aadhaar based authentication, basically linking identity so that whenever you're creating an account for the first time, you'll have to put your Aadhaar based. You have to put your Aadhaar card to ensure that you're not creating duplicates, or no one is trying to scam or robot, or there are any robots issue, etc. Next is for fraud prevention mechanism. The reason why we went with 20% is when you're even doing the 20%, it'll be properly integrated in your payment workflow, such that the money is gonna reach it's gonna reach the server at any cost. When there will be there will be no openness for scamming or anything. This basically now, then for DB, we are using a proper entity relation model structure for data storage. That'll be keep your data secure and of the users and all. Coming to the conclusion, VoyageMate is basically for enhancing the railway ticketing again by improving the convenience, safety, reliability. It demonstrates the transformative potential of AI in large-scale public infrastructure. Our future work, we will be focusing on voice-based booking to prevent delays and all, and real-world deployment. Thank you.
Okay, so Sagar sir, do you have any questions? And this was our last presentation, so.
The problem formulation and problem solution is good. Now all of us waiting for the as actual implementation of your work. Thank you.
Sorry.
Your problem formulation and problem solution is good, but now we are waiting for the as actual implementation. Means it can be
Okay,
useful as an app for the solution,
so
practical
what
solution.
so what we actually did, sir, is that we basically used we did not deploy it in real world, but we tested it with a certain level of audience and a certain level of traffic to check how is the performance of the model.
Yes, yes, yes. I'm saying that we will be happy if it will be implemented in as actual way.
Yes, sir.
Okay.
We will do our we are working on that right now, sir.
Yes, yes.
Thanks a lot. We
Okay,
will
thank
do
you
that.
so much, Charan. So, with that, we come to the conclusion of the technical session 7E. And I would like to sincerely thank all the authors for their excellent presentations and the contributions. So, your work will truly affect the spirit and quality of ICTCS. And I would also like to thank all our participants for staying with us and making this session engaging and interactive. So, as this marks the 10th edition of ICTCS, We are deeply grateful for your continued support, not only this year, but throughout all previous editions. So we look forward to welcoming you again for the 11th edition in 2026. A few important updates before we conclude. All the presenters will receive their digital certificates within 2 working days through their emails. The publication process will be completed within 7 to 8 months of period, and we kindly request everybody's cooperation with the ICTCS 25 team during this publication period. Also, I would like to extend a very special thanks to our session chair, Sagar Shinde sir. So this is a small token of appreciation. Yes, so this certificate is a small token of appreciation on behalf of the team ICTCS 2025 and Global Knowledge Research Foundation and partners. So before we officially conclude, I will kindly request everyone to quickly switch on their cameras so that we can capture this virtual moment together.
Yeah, just a minute, ma'am. I want to share
Yes,
something.
yes. Okay, okay.
First of all,
Yes.
First of all, thanks to Ms. Yashita Mohalle for coordinating the session in all aspects. The way you handle the portfolio is really appreciated. And basically, you are in
Thank you so
line
much.
with your father, Parikshit Mohalle sir, who is a great researcher having the citations more than 3,000 in Scopus database. And he is also having the citations more than 4,500 in Google Scholar, and he have received the research funding in crores. So he's really a great researcher, and it's really happy that you are in line with him. So thanks. And second thing, uh, Dr. Parikshit Mahalle is a very good and global researcher with the great impact in SCS, Scopus, and research funding. And one more thing I want to say, congratulate to all the researcher for the participation in this ICTCS 2025 conference Jaipur. The researcher have been covered the various topics that is ranging from the wireless sensor network, cloud, deep learning, multi-agent co-pilot, cognitive digital shadows, FPGA as a part of semiconductor devices, then neural networks, then predictive recommendations, etc. The many of you provided the solution for the society related problems and good work in the current needs. Good contribution for the sustainable development and the growth of our nation as a research point of view. Thank you. Hello.
Okay, so yes. So there was a network issue on my side, so I was disconnected for a while. So thank you so much, sir, for those kind words. Thank you so much for everybody for your valuable presence and stay safe. Take care, everyone. We look forward to seeing you in the next session. Please switch on the cameras for a second. I will get a screenshot quickly. Yes, okay. Thank you so much, everyone. Thank you so much, Sagar, sir, for being with us today.
Thank you. Thank you.
Thank you, everyone.
Yes. Yes.